so first thing that we got to look at here says 2x squared plus 3x is greater than or equal to 2. That's a greater than sign there. Greater than or equal to 2. Okay, so other than the greater than or equal to sign, we see our 2x squared is squared, meaning the quadratic. So we're probably going to look at using the quadratic formula here. So what would be my first move to get it ready for the quadratic formula? Good. Caitlin, we're going to set it equal to 0, so we're going to move that 2 over. So we would have 2x squared plus 3x minus 2 is greater than or equal to 0. Okay, so now we know we got an a of 2, a b of 3, and a c of negative 2. So we're not doing anything different yet. This is all stuff that we've done last week. Plug that in the quadratic formula and solve. I know I got a greater than sign, but I'm going to go ahead and solve it like normal. Just say x equals negative b plus or minus square root of b squared. So 3 squared is 9 minus 4 times a times c all over 2 times a. Okay, so I haven't done anything new yet. Underneath the radical, and a lot of y'all were still missing this on Friday. Y'all were getting the wrong thing underneath the radical. You ought to know that underneath the radical, your number is going to be bigger than 9. Because you got a negative times a negative, which means positive, which means you're going to add something to 9. Are y'all going to simmer down? So I got 4 times 2 is 8 times 2 is 16. So 9 plus 16 gets me 25. So I got negative 3 plus or minus the square root of 25 divided by 4. That's an easy one because you know the square root of 25 is 5. So you're looking at negative 3 plus 5 divided by 4 and negative 3 minus 5 divided by 4. Those are your two problems that we need to work. Okay? So negative 3 plus 5 on my first one is 2. And then 2 divided by 4 would get me a half. So for this answer, I've got a half. On the other one, negative 3 minus 5 is negative 8. Divided by 4 is negative 2. Okay, so there's my two solutions that I would get if it said x equals that. But it didn't say x equals that. It says x is greater than or equal to that. So anytime we have a inequality, we got to put it on a number line to show our solution. So draw your number line. Make sure you put these in numerical order. Negative 2 is smaller, so it goes to the left. 1/2 is bigger, so it'll go to the right. Now, what you've done when you put those two numbers there is you got to figure out where you're going to shade. You just split that number line into 3 sections that could be shaded. It could be shaded here, it could be shaded here, it could be shaded here. It could be shaded in all of them, it could be shaded in none of them. You're going to have to pick a test point to plug them in and see. Caitlin, if you need to move, but don't act like they do. Okay? So I need a test point first off that's in this category. What would be a number, any number to the left of negative 2? Okay, so we'll plug negative 3 into the original equation. If it makes this inequality true, it'll get shaded there. If it makes it false, we'll leave it alone. So negative 3, isn't that what you said, Rachel? Negative 3 squared is 9, times 2 is 18. 3 times negative 3 is negative 9. 18 plus negative 9 is 9. Is 9 greater than or equal to 2? True or false? Is 9? Yes, Aaron's right. So that section gets shaded. Now, in Algebra 1 and Algebra 2, you put a circle open or closed on it. We learned in this class that also they could use brackets or parentheses. So back to the original equation, inequality, I got a bar underneath it. Which did that mean, a bracket or a parentheses?
Bracket.
Bracket is correct, Sir Zane. So we put that bracket there that way. Alright, now, got to check this section to see if we shade in there. Gut feeling on that is you're probably not going to. Because if this one's shaded, usually that one will be empty, right? Isn't that how you normally see them looking? I need to pick a number in there anyway, so give me an easy number that's between negative 2 and 1/2.
Negative 1.
Okay.
0.
0 would be the easiest one. Chase's wouldn't work. Yours would work, Kaylee, but I'm going to go with 0 because it's easier. Because this would be 0. This would be 0. So is 0 greater than or equal to 2? No. So like we guessed, that can't be shaded. Now I need a number on this section. So a number to the right of 1/2. What's a number that's to the right of 1/2?
1.
1 would be the easiest one for me. You could pick any one of them over there. You could pick 5,000 if you wanted to. 1 squared is 1, times 2 is 2. So I got 2. 3 times 1 is 3. 2 plus 3.
5.
That is 5. Is that greater than or equal to 2? Yes, it is. Zane's got it. So we shade there with a bracket going that way. So that's what our number line would look like. Then before Christmas we went from that number line, dropped it down into interval notation. So we said that goes to the left forever, so negative infinity. Touches negative 2, so it gets a bracket. Union with a bracket around 1/2. It goes forever to the right, which is infinity. So that would be when it tells you to graph your answer, when it tells you to write your answer in interval form. So we didn't do anything there that was new. We've made those number lines before. We've written that interval form before. We've solved quadratic formula before. It's just putting several things together is all. Alright, this next couple that I'm going to look at are the ones that are easy that try to trick you. Get these knocked out and then move on to some other stuff. I got the quantity of 3x minus 2 squared is greater than negative 2. Alright, so before you start trying to solve this, think about what kind, because you're squaring that whole quantity. So what kind of number, positive or negative, do you get when you square something?
Positive.
Very good. Very good thing. Think about 2 positive 2 squared. 2 times 2 is 4. Also negative 2 squared. Negative 2 times negative 2 is also 4. So no matter what we get in that parentheses, when we square it, it's going to turn positive, isn't it? And then so that reads, put it in common sense terms, anything positive is bigger than negative 2. Yes, I mean that's all you can say to that truth, right? Any positive number is bigger than negative 2. So how's that going to be? How do I write that as an answer? If there can be any number for x. Good. Rachel's there. It goes from negative infinity to infinity. Okay, so no matter what, if we plug in negative 5 for x, it would still get us a true statement. Okay? Look what happens with just one little change. Quantity of 3x minus 2 squared is less than negative 2. Y'all already told me no matter what kind of number I square, it's going to be a positive, right?
False statement.
Very good. So I can't have any number squared and it be smaller than a negative. Like Zane said, it's just false. Right? You agree on that? So how do I write an answer for something like that? Nobody knows how to write an answer for a false statement? Good, Rachel. She gave me the Arial writing over there for a no solution symbol. Okay. Alright, those are the weird ones that are easy, but people overlook them and get tripped up on them. Alright, this next one, going back to some ones that we really got to solve a little bit. I got the quantity of 2x plus 1 times quantity of 3x minus 1 times quantity of x plus 4 is greater than 0. Okay, before we get going on this one, because we're actually going to have to solve this one, because it's not a all real infinity one or a no solution one. If I were to start multiplying those three binomials out, is this going to be a quadratic? Is it something I could use the quadratic formula on? No. Kaylee's right, Zane's right. No, it's not. Because if you started foiling the first two, you would get that 2x times 3x, which would be 6x squared, right? But then you'd have to multiply it by that last x, which would make it a 6x cubed. So it takes this up to a cubed, which is called a cubic, not a quadratic. So the quadratic formula, he's out the door. He doesn't work on cubics. Okay? The good news is that this is set equal to 0 already. So all you have to do is take each of your factors, set them equal to 0, and solve little middle school equations. So you'll say 2x plus 1 equals 0, and I'll solve that in a second. 3x minus 1 equals 0, and I'll solve that in a second. X plus 4 is equal to 0. Okay, start solving those. Those are all easy two-steppers. The last one's even just a one-step. Subtract 1 first there. 2x is negative 1, so x is a negative half. Add 1 here. 3x is 1, so x is a third. Subtract 4 here, and that's it on that one. X is negative 4. Now, if you look at the first problem that we did that had two answers, that split our number line into three parts. We've got three answers now. So we're going to have even more parts to do on your checking stuff. Make sure, and I said this earlier, make sure when you get ready to put these on your number line, they're in numerical order. Which one is the smallest that needs to go farthest left? Good, Aaron. Y'all will laugh, but I'll see people that will mess those up. Okay, what comes after the negative 4?
Negative 5.
Good. And then last will be your positive 1 to 1/3. So we've got 1, 2, 3, 4 sections now where you're going to have to do guess and check. Okay, so start on the far left. I need a number to the left of negative 4 that I can plug in. Anybody got one? Negative 5. So that gets me 2 times negative 5 is negative 10. Plus 1 is negative 9. 3 times negative 5 is negative 15. Minus 1 is negative 16. Negative 5 plus 4 is negative 1. Okay? I don't know what 9 times 16 is, but I'm not going to even try to figure it out. Because I got a negative times a negative, which is a positive, times another negative, which is a negative.
That's not right.
A negative number cannot be bigger than 0. Zane's good. So we will not shade that one. Okay? So now pick me a number between negative 4 and negative 1/2.
2. Negative 2.
Negative 2. So 2 times negative 2 is negative 4. Plus 1 is negative 3. 3 times negative 2 is negative 6. Minus 1 is negative 7. Negative 2 plus 4 is 2.
That's right.
Negative times negative is a positive, times another positive is a positive. So that one is true. A positive is bigger than 0. So we will shade between negative 4 and negative 1/2. What kind of marks will I surround that with? Brackets or parentheses?
Bracket on the
Parentheses, because it doesn't have a bar under the sign. So it's just a parentheses on both of them. Now, I got a pretty good idea, because it just wouldn't make sense to have two of them back to back. I got a pretty good idea that one won't be shaded, but I got to test it anyway. So pick me a number between negative 1/2 and 1/3.
1.
1's not between those two.
0.
0 would be good. 2 to 0, 0 plus 1's 1. 3 of 0, 0 minus 1's negative 1. 0 plus 4 is 4. Positive times a negative is a negative. Times a positive is a negative. Negative is not bigger than 0. So our guess was right. We will not shade there. I got one more section. Now I'm ready for that 1, Zane. Bigger than 1/3. How about that 1? So 2 times 1 is 2, plus 1 is 3. 3 times 1 is 3, minus 1 is 2. 3 plus 4 is 7. Those are all positives, so that's going to be positive, bigger than 0, so that one will be true. So that one will get shaded. Alright, so the last step there now, there's your graph, is to write that in interval notation. It's easy to get an interval notation from the graph. Just drop that stuff down, just like it was written. -4 to -1/2, both out of parentheses. When you get a space, and then you pick up another shading that was union with, started at 1/3 and went to forever, also known as infinity. So it'd write like that. Got a couple more to do, and these involve fractions, so we'll get these knocked out real quick. Got -1 over x minus 3 is greater than 1. Alright, very first, okay, that's not the one I want to do, but it'll still work. Very first thing I want to do on that, what can my x, what do I know for sure x cannot be in this? That's a deep thoughts kind of question. Oh.
The positive.
0.
There's a specific number that x cannot be here.
42.
42 it can be, I think. I know one for sure. What can you never divide by? 0. What x would make that denominator a 0?
3.
3. So I know x can't be 3. Okay, so I know that I'm going to have, I don't know how far down to write this, I'll put it up on the top. I know I'm going to have that 3 is going to be important on my number line. Okay, so you go to, when you've got the fraction and it's an inequality like that, you go to your denominator first, knock that out. Now from there we're going to solve it like we normally would. We're going to get rid of the fraction, so we're going to multiply this whole thing by itself, x minus 3. When I take it here, it cancels out. I just got -1. Greater than, here, distribute a 1 to it, x minus 3. Okay, there's just one step to solve that. Add your 3 to both sides. So -2 is greater than x. You could leave it that way and that's fine. But it's easier for me when I just have one piece to shade if I write the variable first. So I'm going to flip-flop that dude and write x is less than -2. Okay? -2 would go to the left of 3. Make sure you put it in the right spot. Less than -2. Less than goes to the left. I don't even got to do a test point there. It's just doesn't have a line underneath it, so it gets a parentheses. But I got to figure out now about the 3. Where do I shade? If I were you, I would test first off what makes sense. It makes common sense to me that it's going to be to the right of 3, right? Just by looking at the graph. So test that first. Plug a 4 in, see if it's true or not. So I'm going to say -1 over 4 minus 3 is greater than 1. 4 minus 3 is 1. So I got -1 over 1 is greater than 1. Well, that's not true. So I was wrong on that. -1's not greater than 1, is it?
No.
No, so I'm not going to shade to the left of it. Check and make sure I'm not missing anything. Well, it was my first section that's the -2. It says it's supposed to be in between them. So let's, I hate it when my instincts are wrong. Let's test, shut someone down. Let's test -3. Because I originally said -3 would make this true. Caitlin, you'll pay attention. So let's test -3 so you can see where I screwed up here. I got -1 over -3 minus 3 is greater than 1. So that's -1 over -6 is greater than 1. 1/6 is not greater than 1. Okay? So what made common sense to me to shade there was wrong. I can't count on my common sense anymore. I got to use my test point. So that should not be shaded. So let's check 0 because it's in between those. 0 divided by anything is 0. Oh, I can't. Zero's down here, doofus. Negative 1 divided by negative 3, right? 0 minus 3 is negative 3. Positive 1/3 is positive 1/3 greater than 1. No? So that won't work. So far I got nothing shaded. What about greater than 3? Checking my 4. Negative 1 divided by 4 minus 3 is greater than 0. Yo, that thing doesn't have any solutions, does it? I mean, I algebraically solved some, but when I plugged them back in to check, nothing checked it out. So it ended up having no solution on that. So mark out that number line I started drawing up there and give that what Rachel says. Not a kid. A no solution symbol. Alright, let's look at another one. To get this one knocked out without me messing you up, be the goal here. I got x plus 2 over x minus 1 is less than or equal to 5. Alright, right off the bat, look at your denominator and tell me what x cannot be. 1. Very good. So I know I'm going to be concerned with a 1. Okay, after that, I'm going to get rid of the fraction. So I'm going to multiply the whole thing by x minus 1. So here it'll cancel out. You just got x plus 2. Less than or equal to. Here you'll distribute the 5. 5x minus 5. Okay, it's not a two-step one there because we got 4 terms, but pick what term you want to start with. What do you want to do to start solving that?
Subtract x.
Okay, I like it, I like it, I like it. 2 is less than or equal to 4x minus 5. Now Kaylee's got to do something. What's she got to do? Add 5. I have an ugly fraction here. 7 is less than or equal to 4x divided by 4. And 7/4 is less than or equal to x. Also known as x is greater than or equal to 7/4. Alright, 7/4. That's bigger than 1, isn't it? Because 4/4 would be 1, so it needs to go to the right of 1. I'm not even going to mess, since I led you wrong with my common sense thinking, I'm not even going to go there. We're going to test all 3 of those sections. So pick a number to the left of 1. 0 is a good one. We got 2 x's to plug that into, numerator and denominator. So 0 plus 2 is 2. 0 minus 1 is negative 1. So I have 2 over negative 1. That's true, right? Negative 1 is less than or equal to 5. Okay, on that, we get a bracket on this. Okay, I don't feel like there'll be one in between 1 and 7/4, but let's pick one anyway. See, I can't even, it's got to be a fraction, doesn't it?
1/2.
Can't be 1/2, it could be 1 and 1/2.
Yeah.
So let's do 1 and 1/2, so I'll do 3 halves, well 1 and 1/2 will work, so that'll make 3 1/2 over a half. Is it less than, yeah, less than or equal to 5, so that's 3 1/2 times 2, which is 7. 7 is not smaller than 5. So we leave that middle section out. Bigger than 7/4, I'm liking 2, good. So that's 4, 2 plus 2, 2 minus 1 is 1. 4 is less than or equal to 5, so that one works. So I didn't mess you up on this one. We got our good looking number line there. So put that in interval notation, negative infinity to 1. 1 gets a bracket, infinities always get a parentheses. Union with 7/4 to positive infinity. So you have that stuff there. Alright, what I'm going to show you for your exit question is written a little funny. So let me get it written, and then that way we get to practice on answering different types of questions. This says x squared plus 2x minus 3 is less than 0. And then it tells us one of our intervals is negative infinity to negative 3. And it asks you, is that true or false? Okay, so what this is asking, because we did this exact kind of problem today, I just didn't ask it the question the same way. If I were to solve x squared plus 2x minus 3 and look at it on my number line, would negative 3 and everything to the left of it be graphed? Yes, true, no, false. Okay?
Like in a gravel?
No, and on just a number line. Okay? And let me make the spot for your true or false, and then you can answer. Now, Kaylee and Kirsten, and if y'all go back and look at that one that I was screwed up on, I made a mistake. If y'all still have it, I'll show you after everybody gets done with the bell ringer. But
What is it?
that problem that I messed up on, I made a mistake in my work. Let's see, which one
Was it that one?
Yeah.
You were done with?
Yeah, so when we added 3,
Mm-hmm.
would have been a positive 2.
Okay.
So that was why it was so stupid on my part.
Yeah.